To start with, okay, trapezoids. All right, we need to first know what a trapezoid is. So a trapezoid looks like we have two bases that are parallel to each other. So I'm going to draw this on one line. I'll skip down two lines and just draw a nice parallel line. Does not have to be the same size. Okay, but that's what makes a trapezoid, is that there are two parallel sides, and those are called the bases. Okay, so I have these two sides drawn, and then the other sides just connect the endpoints. So we can connect here and connect here. Yikes. Alright, so as we take a look at a trapezoid and our bases, I'm going to be using red for bases today. So our bases are the ones that are parallel. That's always going to be important to decide which ones are parallel. Sometimes it's not always top and bottom. It can be side to side. So you just have to really pay attention to how that trapezoid is placed. And then we have a height. And the height goes from top to bottom, or between the bases. Not always top to bottom, I suppose. Okay, and again, we're using that dashed line. What does it mean when we use that dashed line? Is it part of the shape on the outside? Nope. It's just a measurement in the middle. So we have a 90-degree angle, just like we've been having with all of our heights. Okay. Okay, and that is our height. All right, now we have two bases. The bases do not have to be the same, so we call them B1 and B2. We use a subscript, meaning a really small number, so we do B, and then a small number at the bottom, we do a 1. Some teachers, if you hear them talk about this, they might say B sub 1. That just means it's a subscript. Okay. And then B sub 2 is the other one. Doesn't matter which one's which one's 1, which one's 2. We just need to know that they could be different. So we don't want to use the same letter, just B and B. We want to be able to express that. All right, now, as we find the formula, here we go. I have a trapezoid here cut out. This is actually from our first example, but we'll see it in a second. All right, as we take a look at this, here's my base. Base 2 is on top. I have my base on the bottom here. And then I have my height, which is going through the middle. Okay, now if I take this trapezoid, okay, sometimes an isosceles trapezoid I can make a square out of it, but if I cut this in half, right down the middle, as much as I can, okay, here's the trapezoid, cut it down the middle, and then I flip it, it creates a parallelogram. Okay, and we know a parallelogram's formula is base times height. But this time, what is the base going to be? How long is this bottom edge? What parts of this would I need to put together to get that bottom edge? It started here. Yeah, B1 and B2. I'd have to add B1 and B2. No, we just put B1 plus B2. And then how much of the height is being used? Half. It got cut in half. So our area goes A equals 1/2 of the height, because we cut it in the half. Okay, instead of 3, it's now 1.5. Times, and then the base, we need to show that base all the way across. This first base was the B1, but then we're adding on that top base plus B2. Could call it B3, but that is just an extra step that we don't need to do. Camille wants to make you guys do more work than you have to. Throwing you under the bus. All right, so I'm going to color code that. I'm going to use blue for height today, and B1, B2, I'm going to use red for both. So if you'd like to color code, you can. Okay, and that's where that formula comes from, is if we take that trapezoid, all of our formulas really go back to those parallelogram and rectangles. Okay, we do this, we cut it here. Okay, it's half, and that parallelogram area is base times height. All right, you're going to get a glue-in. Your glue-in has 4 shapes on it. I'm going to cut it apart. There's a dash line here. We're going to cut down that dash. You're going to keep the kites, put that off to the side, glue in your trapezoids. Then they can get glued in together right there. Alright, so you can cut that where that dash line is, put the kites off to the side, and then glue the trapezoids Cut out the dash line and then glue in the trapezoids Hi. Hi, Bro. What?
No coffee. It's custard. I've got chemistry with bigger.
Hi, just in time. Morning. Hey, nice job on your test. What do you mean, son? The one for Eagle Time? Yeah, you're good.
I know, but you said I had to do like really good on it. It wasn't that.
It was good enough. It made the cut. All right, here we go. Glue this in. Okay, so today it's just really about making sure that we identify those heights in our B1 and B2 in the right spots. Making sure we know where those go. Okay, so here we go with the first one. Just a second, I've got people gluing it in, sorry. Pausing. I know, sometimes I realize it though. And sometimes I just need reminders because my brain just doesn't calm down some days. You know? Alright, so get that glued in. I'm just gluing in the trapezoid part for now. If you glued in the whole thing, that's okay. You might just need to write your kite formula below it. Saw a couple people get excited and just throw the whole thing in there.
So where do we cut?
On the dash line. Alright. Most people are ready to go here. Got one more person gluing. One person that's just looking at their paper. Okay. A couple people on their phones, not doing anything today. And then they're gonna. Oh, look, I got one. No, it's not. We have done 2 things. Alright, so here we go. The first one, we're gonna say A equals 1/2. Okay, and then I need my height. Okay, we need our height. And then in parentheses, we'll do B1 plus B2. And I'm just putting those parts above so I can fill in the blanks. All right, so in this problem here, what is my height going to be? Good, my height is 3. And then my B1 and B2. Doesn't matter which one is which. Which one do we want our B1 to be? 3 what? Say it louder, Harper. I can't hear you. I'm sorry. 3.6. There's a decimal there. 3.6. And what do we want our base to? 7.2. If you had those flip-flopped, that's okay, because that part we're adding. Hey, you guys. Okay, and so when we add, it doesn't matter which order we add. That's in parentheses, so those can go in either order. Okay, then we throw that in a calculator. And that's really what it is for this one. So area equals 1/2 times 3, 3.6, plus 7.2. And our final answer is going to be 16.2. I'm going to label it with that IN, which stands for inches, but then I'm going to put that little 2 there. What does the 2 represent? Square inches. We're literally measuring how many squares fit inside that trapezoid. There'd be 16.2 squares. Pretty straightforward? Good. Why would we have these 3.5s here? What would be the significance of, or the reason we would label those parts? These sides? Remember, we call these legs. We didn't need them for the formula for the area. What would we use them for? What other thing could we find out about this trapezoid? If I follow the outsides of the trapezoid, what do we call that? Perimeter, yeah. So you'd use those for the perimeter if you're going to do that. All right, so next one we have area again equals 1/2. And we're going to do height. And then our base 1 plus base 2. And we're kind of just filling in those blanks to that formula. What are you doing? What math? You're doing some crazy math over there. All right. So in this one, it's a little bit goofy. Our bases are always parallel to each other. So I always identify my bases first. Which ones are going to be the bases? Is it 9.4 and 3.2? Or 7.9 and 4.9? Good. Again, this one's at top and the bottom. Sometimes it will be side to side. Okay, it doesn't matter which one you put in which position. So you could do 9.4 plus 3.2 or 3.2 plus 9.4. All right, now our height this time, we don't see a dashed line. It's not part of that trapezoid. So what am I going to use for my height? Why? What told you to use 4.9? Good, it has that right angle. It's connected to the bases. That was the right answer too. But 7.9 is also connected to the bases. So we picked the 4.9 because it has that right angle also. Good. Okay, throw that in our calculator. Okay, I don't know why when I use the worksheet creator that I use, it for some reason likes to use decimals on these ones. So we're going to have 30.87. Okay, hey, you two. You're going to have so much more time to talk. Are you talking about the volleyball game already? Oh. I don't know. Isn't ASU hosting a volleyball game this week? Or is that next week? That's this week? Yeah, tomorrow. All right, that's trapezoids. Next up, we're going to talk about kites and rhombuses. So I'm going to do a little star here. If you glued in your whole kites and rhombuses, just do this underneath. Okay, so kites and rhombuses, or kites and rhombi. Rhombi is the plural form of rhombus. If you just want to write kites and rhombus, that's fine. I don't know. Or rhombuses. I don't 100% care. Technically, it's rhombi. All right, so remember a kite looks kind of like the kite that you fly in the sky. We did this way back in chapter 6. Okay, flying kites is one of my favorite activities. With kites, these two sides, the sides touching each other, are congruent. So these smaller sides are congruent to each other. And these longer sides are congruent to each other. A rhombus is very similar, but in a rhombus, all sides are the same. It's kind of like almost like a diamond is a rhombus. So this is a kite, this is a rhombus. That was a really small drawing. I meant to draw it a little bit bigger, but you get what you get some days. All right. This one's a little challenging to try and make it make sense. sometimes. I'm going to do my best that I can with the cutout. Alright, so I'm just cutting out one of these. You are not cutting it out. Do not actually do this. Okay. So here I have the kite that we're going to do in the example in just a moment. And to find, again, this, we're going to cut it in the middle. So if I actually cut it down this diagonal, and then I kind of try to flip it, I'm going to have to flip this upside down, but it does end up creating a really weird parallelogram. So I have to cut it in half, and then I have to also like rotate it to get there. But what's goofy about this one is now what is this length, this base? What part of that was that in the kite originally? It went down the middle. Does anyone remember what do we call those parts that go down the middle of a kite or a rhombus? It starts with a D. Close. Diagonal. Diagonal. Okay, so this is a diagonal, and then we have a diagonal here, but what did we do with that diagonal? Cut it in half. So our formula is 1/2 of that diagonal times the base. So it's 1A equals 1/2. And again, we have two diagonals, so we use lowercases d's for these, and we use those subscripts, so D1, D2. And they're right next to each other, so we're multiplying. I'm going to switch colors here because that's just what my brain tells me to do. You can use the same colors we were just using. I'm going to use green and yellow. So I have D1 and D2. If I take a look at that here in my kite, that would be going across this way and then across this way. If you're not using colors, you should at least draw those in. But they connect corner to corner, so these are diagonals. All right, we have two quick examples. Hey, you three. I'm going to send you out of class to kick you out. All right, if you have space to glue in this whole thing, you can glue it in. If you want to cut it apart, last year I had to cut mine apart because I took up too much space. And you can glue it 2 and 2. The work for this does not take that much space. I personally would try and get it to fit on one page as best you can, but I don't know. Probably not worth it if you have to. You're going to cry. I don't know. That's too much. Then just don't do it. Okay. So again, this is pretty straightforward. Shouldn't take us too long to do. After you get that glued in, that's going to be the hardest part. Just gluing this in. Like seriously. Just like pretend to care. It's literally going to be like 3 minutes, and then you can have the rest of the time to chat, whatever it is that you guys are chatting about. All right, so in this first one, we're talking about our diagonals. So it's going to be A equals, we have 1/2, and we're doing diagonal 1 times diagonal 2. And we like to use parentheses for that multiplying. So as I look at diagonal 1 and diagonal 2, doesn't matter which one's which. Okay, so I'm looking through the middles here. So I'm going from this corner to this corner. And what number actually represents that full length? Yeah, that's really this 15. Good. So for D1, I'm going to use 15. And D2 is the other one going corner to corner, across. Those of you that had me last trimester, if you remember, flying kites is like one of my favorite activities. Super excited about doing it this spring. Okay, so as I go corner to corner here, what's that length? 8. Now you can put this in any order. It didn't matter which one is D1 and which one's D2. So if you were working ahead and you filled it out 1/2 times 8 times 15, we're going to get the same answer. Okay, because it's multiplying, and the multiplying has the commutative property, so we can move things around however we want. All All right, in my calculator, if I did it the other way, it might be easier to have multiply in my head. What's half of 8? 4, and then 4 times 15. It's like 4 15-minute sections. Oops. Would be 60. Okay, anytime we multiply something by 15, we can always think of a clock, like how many 15-minute segments would make that. So 4 15-minute segments would be 60 minutes. That would be an hour. If you didn't follow that, that's fine. Use a calculator. 60 square meters. All right, next one is pretty similar, but this one is a rhombus. And one property we learned about rhombuses back in chapter 6 is that the diagonals cut each other in half. Does anyone remember that word that means that they're cutting each other in half? It starts with a B. Bisect. Good. The diagonals bisect each other, so they cut them both right in half. So on this one, we have to do a little bit of math. Not a lot of bit of math. We're still going to do half of something times something. But I want the full diagonal. So I need to go the whole way across. Right now, this 10 is only representing from the corner to this intersection. So if that part is 10, how much is this other part? 10. So altogether, how long is that length? 20. Okay, and there's going to be a problem like this on your practice, and there's going to be a problem that kind of looks a little bit like this, but for kites also. So 20, that was a weird looking 2. Okay, and then my other diagonal going the other way. 12 is just from the corner to the intersection, so how long is it from corner to corner? 24, good. So 12 plus 4, we're just doubling it. Could think times 2, or you could think adding by itself. This one I'm sure we can do without a calculator. What's half of 20? 10, and then 10 times 24? 240. Anytime that we multiply something by 10, we just add in a 0. So half of 20 was 10. 10 times 24 is 240. Now I'm going to write this. Does anyone remember how do we say this, though? Dang, Camille's got this. Square feet. Okay, it's really tempting to say feet squared, but we're not. Feet squared doesn't really make sense in the real world. We would say square feet because we're actually talking about how many squares of feet fit in there. All right, nice job. That is you.